Let's take a look at quadratic functions. Now for our quadratic functions, we have something called standard form. Standard form is when it's of this form. F of x is equal to a times x minus h squared plus k. And you have it in this form. There's various things you can tell about it. Now, first off, if a is positive, if a is greater than 0, then your graph is going to open up. If a is less than 0, if a is negative, a is just a number, then it's going to open down. Your vertex is of the form hk. Your axis of symmetry is going to be x is equal to h. And your min or your max is going to be your k value, your y value here. Well, I say min or max. If your graph opens up like this keeps going forever, going up. So it doesn't have a high point, but it does have a very low point. This is the lowest point the graph has. So this one has a min. Now this one, if my graph is opening down, these keep going forever. So there is no low point because it keeps going forever. But there is a high point. This is our max. Now we're going to see that the vertex actually happens to match with our lowest point or highest point, depending upon whether the graph opens up or down. Let's take a look at this first problem here. It says the graph of a quadratic function is given. Choose which function would give you this graph. Well, remember what our basic graph looks like for f of x equals x squared. That's here's y is equal to x squared from our basic graphs. It looks like this. Now if we put numbers with it, then it shifts it. Remember, if a number's at the end, it shifts it down or up. This -1 here would mean down 1. Well, this doesn't look like a shifted down 1. It actually looks like a shifted up 1. So it's either going to be a g of x or j of x. Now remember, if the number's inside with the x, it's left or right, opposite of what you think. This plus 2 means left 2. So this g of x would be left 2, up 1. Left 2, up 1. Well, that's not where this is. Now the j of x. The -2 here, again, it's opposite of what you think. So that means right 2, up 1. Right 2, up 1. So j of x is the match for this. Now if you remember those, fantastic. If you don't remember those, and well, you should refresh your memory. If you're going on in math, you should be able to look at those and see which one the answer is. But if this is your last math class, college algebra is where you're stopping. Plug in your graphing calculator, see which one it matches. Let's take a look at this one. And again, they want us to match up the function with the graph. Well, -1, I know what that does. It shifts it down 1. Negative before the x squared, that flips it upside down. So it's not h of x, it's not j of x. It's either f of x or g of x. Now f of x is equal to x squared plus 2x plus 1. And g of x is equal to x squared minus 2x plus 1. Both of these factor, sorry. This will factor as x plus 1 squared, and this one factors as x minus 1 squared. Now remember a number inside with the x shifts left or right, opposite what you think. So this right here is saying shift left 1. This one's saying shift right 1. Well, this has been shifted right 1 place. So it's going to be g of x. And that's our answer to that one. Now we could have also used some knowledge about the vertex to help us figure this out. But these first ones, the shifts are just fine on. Let's take a look at number 3. We've got f of x is equal to -5 times x minus 3 squared plus 7. And instructions say find the coordinates of the vertex for the parabola defined by the given quadratic function. Well, this is in standard form. See, we have x plus or minus a number squared. It doesn't have to be a minus here. It could have been a plus 3. We have a number at the end. We have a number before parentheses. So this says if you have it in standard form, you need to identify your h and your k. Now h is a number that's inside with our x. And it's always going to be opposite sign. So h is going to be a positive 3 since that's a negative 3. Now our k is a number at the end, and it's going to be the same sign. So k is going to equal to 7. Why? Why is one of them opposite sign? Why is one of them same sign? See how we have a negative in the formula here? That's why that one flips signs. And this one's a positive, so that's why it's the same sign. So now that we've identified h and k, our vertex is h and k. So our answer would be 3, 7 for our vertex. Let's take a look at this next problem. Got f of x is equal to x minus 4 squared plus 1. The instructions say find a vertex, axis symmetry, min or max, and then graph. This is slightly different than what the book has. I like my instructions better. So this is in standard form. So let's identify some items first. The a is whatever number is here at the beginning. Well, there is no number there, so it's by default 1. Now I don't know much about this graph yet, but if a is positive, that means my graph's going to open up. Your h is whatever's with your x, and it's opposite sign, so this will be 4. And our k is the number at the end, and it's same sign, so k is 1. Okay, so our vertex. Our vertex is hk, which is 4, 1. Our axis is symmetry, and I'll abbreviate it, AOS. Our axis symmetry is x equals, and then the x part of our vertex, which is 4. So x equals 4. Now our graph is opening up, which means we have a min. We have a low point. So our min will be 1. Put it to y value. Now some books will put this in point form, some will put just the y value. Now let's graph this. So vertex is 4, 1. So I go to 4, 1, and I put my dot, my point. And I know it opens up, so I kind of have an idea what already it's going to do. What the book implies is they want you to find the intercepts to help you get the graph. Sometimes the intercepts is hard as can be to get the graph. So if you're doing this by hand, instead of doing the intercepts, pick a point. Doesn't matter what point, but pick a point. Like maybe I'll pick 2. So if I pick x equals 2, plug that into your function and see what the y value is. So we got y is equal to, remember f of x and y are interchangeable. And then I'll put 2 in for the x, so I got 2 minus 4 squared plus 1. Well, 2 minus 4 is negative 2, and negative 2 squared is 4. So we got 4 plus 1, or 5. So we would have a point 2, 5. So 2, 3, 4, 5, 2, 5, I put a point. Well, our axis symmetry is at x equals 4, and let me draw that. That's axis symmetry is an invisible line, vertical line, and it passes through your vertex. Okay, so now I got that one point. I generally know what these look like, so that's going to go up like that. Now, since this is the axis symmetry, since I got my left side, all all I have to do is flip it across that axis symmetry, and that'll give me my right side. And that'll give us our graph, just sketching. Now I could have done a few more points to get it. Now if I had plugged in, tried to find the Y-intercept. Remember, to find a Y-intercept, you plug 0 in for x. If I put 0 in here, I get negative 4 squared, which is 16, plus 1 is 17. 17 is way up there. So sometimes the x-intercept and y-intercept are very impractical to get. Sometimes it's just as easy to pick a simple point like here. I could have picked x equals 2, x equals 1, x equals 5, 6, something like that. Well, let's do this on the calculator. So I'm going to press my y equals. Now I have my statistics turned on from previous video I created. So I'm going to up arrow, highlight plot 1, and press enter on it. And then down arrow. That'll take the highlighting off of it. You shouldn't have to worry about that yourself. Now I'm going to press clear. I'm going to do zoom, choose 6 for Z standard, set it back to where I am. Okay, now it should be where you are. So press y equals. Press clear to clear out whatever's on y1. And we just type it in as we see it. So I do a beginning parentheses, x minus 4, closing parentheses, x squared, plus 1. And then graph. And we get the same picture more or less. Theirs is better, but well, I don't know if it's better or not. They're both just sketches. Remember, this is not a square setting here, so that's not actually our picture. If I were to do a zoom and choose Z square, our fifth one, we would get a better picture of what it should look like, which is closer to what I actually did. But we always go with zoom Z standard, because again, we don't care about precision on this. We're looking for just a sketch. So anyway, that's our graph. Let's see, is there anything else? Vertex, axis symmetry, min-max, and then the graph. Okay. Well, let's talk about if it's not in standard form. If you got it in your general form. If we have f of x is equal to ax squared plus bx plus c. Well, there's still some things that help us tell something about this. If a is positive, a is greater than 0, your graph's going to open up. If a is negative, your graph's going to open down. Now our vertex, we have a formula for it. They call it actually the Vertex Formula. It goes like this: negative b over 2a, and then f of negative b over 2a. Now our axis of symmetry, and I'll label it as AOS, is still x equals the x part of our vertex. So negative b over 2a. And our min or max is still the y part of our vertex, which is f of negative b over 2a. Now let's look at, I'm going to create a new page here, but let's look at a problem dealing with that. We've got f of x is equal to negative 3x squared plus 12x minus 1. Now the instructions say find the coordinates of the vertex. Well, this isn't in standard form, so we have to use our vertex formula. So finding the vertex. And again, this is when it's not in standard form. Our first step is to identify. Now, we don't have to identify all the pieces. Well, I've erased the formula, but we identify A and B. Let me put the formula up here. This is from a page we just did. Vertex formula is negative b over 2a, and f of negative b over 2a. So we identify a and b. Now a is the number that's before x squared, which is negative 3, and b is the number that's before x, which is 12. Now step 2, plug these values into negative b over 2a and simplify. So I got negative b over 2a, and so we said b was 12, so I plugged 12 in for the b, and a is negative 3, so I plug that in for the negative, for the, plug that in for the a. Sorry, mind's wandering. So I got negative 12 over negative 6, which gives us 2. This right here is the x part of the vertex. So that's the x part of the vertex. Now, plug this x value into the original function and simplify. So now plug that into the original function and simplify. Well, this is our original function, and we just said x was 2, so we're going to evaluate f of 2. Remember, evaluating a function, everywhere you have an x, you put in parentheses. And then we're going to plug in 2 inside of those parentheses. So plug 2 in there. Well, we got negative 3, 2 squared is 4, plus 12 times 2 is 24, minus 1. That gives us negative 12 plus 24 minus 1. Negative 12 plus 24 is 12, minus 1, which gives us 11. This is the y part of the vertex. So that's y part of the vertex. So our vertex is 2, 11. And that's our answer. Now, all those words I just wrote, that's exactly what this vertex formula is saying. This is saying identify a and b, plug a and b into this portion, simplify it, and then this f of that says plug that into your function. So, neat part about math is you got symbols that shorten a lot of this, so you don't have to write it in a whole bunch of words. Well, let's take a look at this one. This one's going to ask us to find everything: the vertex, axis symmetry, min or max, and then graph. So we've got f of x is equal to 2x squared minus 5x plus 1. Now, to begin with, I know it's my a is what's before the x squared, so a is positive. So I know my graph's going to open up. Now, opening up, I know it's going to have a min. So there's some things that right away that a tells me. If a was negative, it would open down and we'd have a max. Well, let's first find our vertex. Remember, for our vertex, we're going to identify a and b. A is the number that's before your x squared, which is 2. And b is the number that's before your x, which is negative 5. Then the second thing we want to do is we want to plug those values into negative b over 2a and simplify. So we have negative 5 over 2 times 2. Negative gives us a positive 5, and 2 times 2 gives us 4. And again, that's the x part of our vertex. Then we want to take that value and we want to plug it back into our original function. So everywhere I have an x, I'm going to put in 5/4. Well, 5/4 squared is 25/16 minus 25 over 4 plus 1. This 2 and this 16 reduce, and that gives me 25 over 8 minus 25 over 4 plus 1. I'm going to go ahead and rewrite all of them with the common denominator. So that would be 25 over 8 minus 50 over 8. Multiply the top and bottom by 2 plus 8 over 8. 25 minus 50 is negative 25. Negative 25 plus 8 gives us negative 17. 8. Let me double check myself in the calculator on that. Sometimes basic math eludes me. Plus 8. Negative 17. Yeah, that's right. And this is the y part of our vertex. So our vertex is going to equal to 5/4 and negative 17/8. Now let's think about what those represent. If I plug those in my calculator, that's 1 1/4, 1.25. Let me double check that. 5 divided by 4, 1.25. So that's like 1.25, and 17 over 8 with a negative out in front gives us like negative 2.1. This is approximately equal to that. We'll come back to that. Now our axis of symmetry. That's going to be the x part of our vertex, so x is equal to 5/4. We've already said that this opens up, which means we have a min. So our min is going to be negative 17/8. Sometimes that's written in point form, like I say. Okay, let's come up here. We know our graph opens up. We know the vertex is 1.25 and negative 2.1. Okay, 1.25, so maybe right here, negative 2.1, maybe right here. If you're not sure you got it in the right place, make your dot a little bit bigger. You're covered. Now I want to pick a point to plug in, if I was doing it by hand. Now my original function was f of x is equal to 2x squared minus 5x plus 1. Now, almost your perfect one to pick usually, the last graph I did in this section doesn't work out that way, but is to plug in x equals 0. Now remember, f of x is the same as y, so I can interchange those. So then this is 2 times 0 to the fifth. Let me try it again. That has to be squared. We're quadratics, not the fifth power section. Let me double check what else I did there. Okay, minus 5x plus 1. Okay. So we got 2 times 0 squared minus 5 times 0 plus 1. 0 squared is 0, times 2 is 0, 0 times 5 is 0, so those drop away. We got y is equal to 1. So we know it passes through the point 0, 1. So I come here and put a point. Now our axis symmetry passes through this vertex, like that. I found this point, so I can should have a little bit more of a curve right there than a straight line, but we'll pretend that's correct. And then by symmetry, I'll flip that across this, and that'll give us. Try it again. Okay. Boy, I just stink freehanding this. That's as close as I'm going to get. That should look like a parabola. Well, let's plug it in a calculator and see what it looks like. That's where you should go for a decent sketch. I say sketch because even though it's halfway precise, it's still not like a computer program would give you. It has errors. So I went to y equals, press clear. I'm putting in 2x squared minus 5x plus 1. And then graph. And that's what mine should have looked more like, but I think you get the idea on that. But anyway, that's our answer. Let me start a new page here. We're actually going to come back to that problem after I work the last problem. Okay. 7. We got f of x is equal to negative 2x squared plus 10x plus 3. And instructions here say determine whether the graph has a minimum or maximum, then find it. Well, remember, to find a minimum maximum, you find our vertex, and the y part of our vertex is our minimum maximum. Well, to begin with, a is the number that's before our x squared. Here, a is negative 2, which means the graph opens down. And since it opens down, that means we're going to have a max. So we know that part already. So let's find our vertex. Remember, our first step for our vertex is we identify a and b. A is the numbers before your x squared, which is negative 2. And b is numbers before your x, which is 10. And then, using the vertex formula, we want to plug those values into negative b over 2a. So that gives us negative 10 over 2 times negative 2, which gives us negative 10 over negative 4. The negatives cancel, and 10 fourths gives us 5 halves. Well, step 3, we then want to take that value and plug it into our function. So I'm going to have negative 2 times 5 halves squared plus 10 times 5 halves plus 3. That gives us negative 2 times 5 squared. 5 squared times, 5 times 5 is 25. 2 times 2 is 4. Over here, the 2 and 10 simplify. That gives me 5 times 5, 25, plus 3. These reduce. That gives me negative 1 times 25. Well, let me just go ahead and do it. Negative 50 over 4 plus 25 plus 3, which is negative 25 halves plus 28. I'll get a common denominator of 2, and this would become 56. Combine these together, and 31? Yeah, 31 halves. Now we said that our graph, what did we say our graph does? Okay, our graph opens down, which means we'll have a max. So our max is 31 halves, and sometimes they'll write where it occurs. It occurs at x is equal to 5 halves. Now, on the test, I'll put in nasty ones like this, come up with fractions and so forth. It doesn't bother me at all, because we have a nice graphing calculator that'll handle the fraction perfect. So if I come back to here, if I do second mode, and I'll put in negative 2, beginning parentheses, 5 divided by 2, close parentheses, then squared, and then plus 10, beginning parentheses, 5 divided by 2, closing parentheses, plus 3. And if you press enter, and then you get a decimal, if you do math, enter, that'll change it to fraction, and it's 31 halves. So again, I like to put fractions on there because then those who need to practice the fractions can get it, and those who stink at fractions, well, you can plug in your graphing calculator anyway, so no need to whine. So that's our answer. Okay, let's go back to this one I promised. We got f of x is equal to 2x squared minus 5x plus 1. And this is, some people like to use this method instead of using the vertex formula and all that. What they do is they rewrite it. They take it from general form to standard form. And what we're going to do first is factor out the number in front of the x squared. and just from the x squared and x term. So factor out the number in front of the x squared. In some problems you don't have to do this. So I'll factor out the 2. And this one's not going to come out pretty, it looks like. Like that. Then we want to complete the square inside the parentheses. Now, if you remember completing a square, we take the number that's before our x, which is negative 5 halves. We multiply it times a half when we square it. It's always times a half. It's always squared. So that gives us negative 5 fourths squared, which gives us 25 sixteenths. Now, in this manner, we're going to do it a little bit different. It's kind of weird. We're going to take our x squared minus 5 halves x, and we're going to add 25 sixteenths. But we're also going to subtract 25 sixteenths. Now, if you're happy with the vertex formula up above, just stick with that. You don't need to do this. Now, we're going to, now if you love math, then you should be really enjoying this part. We're going to group the first 3 terms together and group the last one by itself inside the parentheses. And we're going to take this 2, and we're going to multiply it times the first group, and we'll multiply it times the second group. So this gives us 2 times x squared minus 5 halves x plus 25 over 16. And we'll take 2 times negative 25 over 16 plus 1. Now you may be wondering, well, why did you add it and subtract it? Well, we can't change its original value, and 25 over 16 minus 25 over 16 basically gives you the previous step. So we haven't changed its actual value, just the way it looks. Well, remember, with completing a square, we want to factor this now. So this is x minus 5 fourths squared. And 2 times, well, the 2 and 16 reduce. That becomes 1, and this becomes 8. So that gives us minus 25 over 8 plus 1. And this is a mixed number, so I could use that mixed number rule. We take the number here, the 1, times the 8. That gives us 8, plus the negative 25. And that gives us negative 17. And then your denominator stays as is. And now, all of a sudden, this is in standard form. And we can easily identify the vertex and everything. So our vertex would be 5 fourths and negative 17 eighths. You know, our axis of symmetry is x is equal to 5 fourths. And our graph, the A is, what is the A? Positive, so it opens up. So we have a min at negative 17 over 8. Or min of negative 17 over 8. Again, if you don't like completing a square, then you probably don't like this. Some items to note. When I factored that, I just took whatever numbers right here, right before you square it, sign included, and put it right here. So, anyway, I just want to show you that technique. And that's actually the end of that section. So.